Yeah, just wave me if it disappears. Alright, so I'm Adam, I'm a senior engineer at Container Solutions. I'm an ex-Java developer. I still develop Java, but these days I mostly spend my time with Kubernetes and containers and stuff. So this talk came out of mainly my experiences in my previous life of building applications and testing them, and throwing in a bit of container goodness into the mix, so I can show you guys some cool stuff that I learned since I joined Container Solutions. Yeah, so the good old testing pyramids and microservices. By the way, I stole this picture from occultphysics.com. It's really cool, check it out, there is some crazy shit there. I was just like, searching on Google for some pyramid picture and I found this. It's amazing that people have time to write on the internet. Alright, so microservices. Let's start just setting up some basics. So who hasn't heard a gazillion of talks about microservices already? Okay, so just a quick introduction. Microservices are now the buzzword for architecting your application for the cloud in a way as to make it scalable, make it more easy to run in the cloud by basically splitting it up into components that all run as a independent process. So instead of componentizing your application using a huge Spring descriptor with lots and lots of beans created, you try to make the breakdown into services that can independently run as a process. That's good because then you can run several instances of those when you need to. Especially in the cloud, you can't easily scale up a virtual machine, but you can easily, or especially you can't scale it down if you put in a bigger one, but you can start up a lot of virtual machines or containers. And then your application needs to be architected in a way that it can actually take advantage of that. So if you make all your components into services that have an HTTP or SOAP or whatever gRPC API, can talk with remote services, then you will be able to take advantage of these nice features of public and private clouds. That's the gist of it. And so this talk is about how testing is affected by changing the application's architecture. So there is the good old testing pyramid telling us that we should write lots of unit tests. Then in the middle, well, before I wrote microservice there were component tests, and at the top everybody calls it something else, but it's usually system tests or end-to-end tests. I picked end-to-end tests, it's nice and short, it fits into the little triangle. So I honestly don't really care about the pyramid shape of it, but it's a nice word and it's nice to remember. It's a nicer graphic than drawing the testing box or something. So it's not necessary. I'm not sure if it's always a good idea to write more unit tests and then less in the middle and then even less in the top. People do it different ways, and I've seen it done successfully with just end-to-end tests, for example. But how the picture changes with microservices, well, the short answer, it actually doesn't change it that much, but there are some pitfalls that people do fall into. So let's go over these different types of tests one by one. So unit tests, yeah. I will also tell the definition of them because it's not always, there is no exact definition sometimes what the hell the one or the other layer means. People define it differently, so I will make sure that we are on the same page. So unit tests are tests that test code in isolation, that don't start up a full service process, don't call an HTTP API, they just test a class or a set of classes by just bootstrapping them in memory and run some tests against them. So that's unit tests. Unit tests practically aren't affected by microservice architecture at all. Well, if you make your services very, very, very small, then maybe you don't really want to do unit tests, but that really depends. So unit tests, stay unit tests, is the English verb. By the way, feel free to interrupt me with questions. Yeah, so the next level, component tests. As I said, components become microservices. So of course you will still have beans and stuff inside your microservice. So microservices themselves are little monolithic applications, but yeah, for this purpose, it's more useful to talk about them separately, or like talk about them as a separate kind of thing. So they are independent processes. They have usually the common thing to do is some HTTP, usually REST API, and they can be load balanced and auto-scaled. That's the quite interesting part already, because you want to test that. And it's not necessarily on the microservice test level, maybe on the end-to-end test level, but that's an important distinction from old school monolithic components. So yeah, so we will want to write tests for microservices, especially since another aspect I forgot to mention about microservices is that on the one hand, the ease of running things on the cloud was the driver behind microservices, but the other driver was for big companies to actually be able to put lots of teams on a large application. So usually a microservice would be developed in such a company by an independent team. There is, of course, smaller companies will not do that exactly. That's again just the pure theory, but let's say Netflix does it that way, or Amazon. And in that case, every team will, of course, make tests for their own microservice, like everything possible. So that's their duty, responsibility to automate tests, and then they go up to this level in the pyramid. If you're a smaller company and you just architect your application as microservices, but you still have one team, then how many tests you want to write for a microservice, that again depends on the complexity and stuff. So yeah, so the microservice tests are pretty clear. You start up one process and run tests against it. Anything that you will need to mock, of course, other services that it's connecting to, and it can get a bit more trickier because, well, you have to actually start those services again as something that is listening on a port, which is not that easy as just hooking up some Spring Beans in a test configuration. But actually, the main focus of my talk is the end-to-end tests. So let's say we have a microservice application. I will show something more concrete later, but for now it's just this beautiful diagram here. So we have a bunch of backend services with APIs and a front-end service that has a web interface. So how do we test real scenarios that we actually want to see, want to make sure that the application can successfully execute? So there is two pitfalls I want to show that I have seen teams making or falling into. First is that when everything is based on the fact that all of these have accessible APIs, all the microservices. So people start using them, and that's when things go wrong. So first of all, people start testing the microservices using some manual tools. Let's say they go beyond curl and start using, I have seen my main experience was with SOAP UI for SOAP-based services. So it's very nice until that you can click, make some requests, see some responses coming back, and then you're drawn into, okay, so I make a bunch of requests, And then okay, so I could actually run these as a test automation suite, and then you actually SoapUI gives you support for that. I guess other tools for REST also have that same kind of support. It can be run as a jar file, provide the tests, give the SoapUI jar file, and Maven can. It's so good to be on a Java meetup. Like I can just say things like Maven, not have to explain them. It's great. Also screen. So yeah, so Maven will run them. And then you start making more and more SoapUI tests. Also, the business analysts are very happy with SoapUI because they can click, and although they have to understand a lot of technical details, but they don't have to touch code, and that's somehow better. Yeah, but what's the problem with that? That there is practically no abstraction. Okay, the APIs of the services you're calling, those are of course a level of abstraction. That's not bad. That's why. Yeah, of course, those APIs need to be thought through quite thoroughly. So if I go back on the picture, so yeah, these all are already abstracting things away. That's good, but still, those will be prone to change. Also, if you're making pure HTTP requests or SOAP requests from SoapUI, you are encoding a lot of technical stuff inside the tests. And over again, because every single request will have it specified that it's an HTTP basic authentication, for example, or that the URL parameters are done in a certain way, etc. And then you have lots of tests, and when you make the smallest change, then you have to change all of the tests. That's the very simple thing. So yeah, don't use these kind of tools for your automated tests. You use them for manual testing, that's completely fine, but don't use them for manual testing.
And manual assistant.
Yeah, or for automated, yes.
If you show us the form slide.
This one or this one?
Yeah, this one.
Yes.
Actually, if you're talking about E2E tests, actually you are looking at this as one system.
Yes.
So what's the entry point of this system?
Yes. So that, yeah, good point. I should explain. Yeah. So usually, well, the web interface will be. So a lot of times you might end up with UI clicky tests, Selenium, etc. But you will have functionality where you will skip the web and need to do something on the backend, maybe because it's easier, maybe because that's not even user exposed functionality. So your entry point can be anything. There is no right solution there, but that will be actually the second pitfall. Yeah. So yeah, there is no like definition of what the entry point is, but make the entry point, so think in terms of, and that's the second pitfall. So yeah, so they all have accessible APIs. So you are drawn towards like making test one call the web, then check something in the backend system, test two will call the web, do some other stuff in the backend systems, and your test will again have encoded a lot of details about how the application is made, how it's working.
If I
Yes.
try to make summary, actually I'm saying the entry point of the application of the system is not well defined. It's very
Yes.
brittle. Actually, can.
Yes. Yeah. It's not well defined. It's like it really depends on the application, right? I mean, for a website, it's pretty clear. For let's say on GitHub, you have the web and you have an API exposed. So those two can be, maybe you can do everything there, but maybe you still want to execute some things using just certain backend services.
Okay.
So there is not a clear line in this.
Okay. Clear. Thank you.
So yeah, so the simple solution to this problem is just abstract it away. So write a test framework that will look on this application exactly as one system, will expose an API outside that will on one hand make it easier to write tests, and on the other hand, when things do change inside the application, you just change the testing framework. It's nothing really fancy, but why I saw teams skipping this part was because it was so easy to just call any API here. It's like And that's a new thing with microservices, because the monolithic application, once you have settled that your end-to-end test will run against the running process, at that moment you don't have access to your internal beans and stuff, so you can't call those. But with a microservice application, suddenly it all becomes naked, it's all the APIs are out there, and you can just call them and make some really ugly assumptions in your tests. So that's the whole thing. Write some kind of testing framework. I'll go into a bit more detail once I check what's that's something. So people who use BDD before, who did do BDD, then yeah, this is BDD.
So it's a separate component.
Sorry?
So like the test framework is like a separate
Yes.
component that abstract.
Yes, the application that gives you. I will show a nice example of
You
it.
also run it somewhere.
Yes.
In the server.
And it's what's interesting is that it's application specific. So that's also why people are like hesitant to write this, because sometimes I was like advocating for this, then people are asking, but isn't there something out there already? Well, no, there isn't, because this is the API for your application. So there is no, you can find like Cucumber can help with defining that API in a nice way, but that still doesn't solve you the problem that you have to model your application for the outside world, which is in this case the tests themselves. So yeah, is that point clear? I mean, there will be examples and stuff still, so okay. Yeah, so I will be showing you our socksshop. It's a microservice reference application. I will be using this one. It's a web shop implemented as a microservice application. Lots of polyglot programming, every service in all possible languages and stuff. Mostly it's Go and JavaScript and Java. And we just did a .NET service in there. That's .NET on Linux. My colleague Lukáš could tell you about that. It wasn't a pleasant experience, apparently, or like it was very hard or much harder than.
I guess he was using .NET Core.
Sorry? Yes. So .NET Core was fine. The lack of libraries was the problem. Yeah. And this was not something with a UI or anything very like Windows components or something. This was just a web service. It's actually the order service, which now we have both in Java and .NET. Yeah, so this is the application. So the front end is actually orchestrating the whole thing. So when it's building up a page, then it's pulling data from lots of services, and then the order service is pushing data to the back and shipping it to RabbitMQ, and then the queue master. That's like I think something that's just a dummy service to pull the messages out of RabbitMQ.
Can I have a question?
Yeah, sure.
Like, so every service in this example has like some of them are accessing database. Is it the same database, or every microservice has its own database?
Yes, every one of them has their own database. Yes. Okay.
And
yeah, that's again a pattern we could go into with microservices. Okay. So and that's where it becomes even more interesting. Maybe in the next talk.
Okay.
Or we have a beer later. We can go into that. But yes, those are all separate databases. And as they don't necessarily have to run actually as separate databases. You could keep them in one database but separate schemas. That would also be doable. That would still not upset the architecture where your services are not supposed to depend on each other. They are separately releasable. So
yeah, but I guess they are dependent on each other or not?
Not on each other's data schemas. So they are dependent on each other's APIs, not the exact way how the data is stored in the database. So that makes a difference. Okay. Yeah. So what's next? Yes. So containers and microservices. Now this is the point where I want to show you the code, which is. That's the code. All you're gonna see today, it seems. Ooh. Actually, my map is freezing also. It's not just the screen. Okay, I'll like save it before it explodes. Well, okay, IntelliJ gave up on me. Let's see. Should do now. Of course. How much time do I have, by the way? Oh, yeah, I see. It's not much time. Oh, it turned off? Oh, it's booting up, right? IntelliJ is booting up also. Why did it turn off?
Probably lost signal. Power signal.
But it doesn't, well, it shouldn't probably turn off like in 2 seconds already. It's a bit strange, but it's working, it's working. Okay. Okay, now I would like to start IntelliJ. Like, not a background window, but I'm not in full screen because maybe that was the problem. But, let's do it. Okay. Okay, yes. Yes. Okay. So, yeah, let's see the customer registration test. Very simple one. So this one, this is my first test that I did for the socksshop. It is written as a Java Fluent API. I like that style. The other option would be to do Cucumber, or probably a dozen others, but these are the ones that, yeah, so I actually did it always this way, and I have some Cucumber tests to show also, to just show to those who don't know them. But the point is here that if you read this test, there is nothing in there that isn't really relevant to the test. There are no implementation details. You don't even know which services it is talking to. Okay, here we say front end, so yeah, okay. That much we are exposing in the test, that we are actually talking to the front end, but even that we could take away from there. So it says register this user, log in with the registered user, verify the customer. We are, yeah, this is the best fancy way, so we are passing in a closure which will receive the customer, because we are not having state here in the test, so we're not returning variables, so we need to do it this way. I think it's still pretty nice. And we delete the user, and this end front end isn't really necessary. This would be necessary here. We would continue with another component or something, but that's fine. Yeah, so this is a high-level view of the application. This doesn't deal with any internal details, no HTTP calls, no nothing like that. The implementation is a bit complicated, not like super easy, but again not so hard either. So we are using UniRest to do some post calls to the endpoints. Yeah. And always waiting, so that's also I think so. Like yeah, in these end-to-end tests, I found it a very good pattern to always wait for the success condition, unless it's something there you can like mess up the application if you call it multiple times. But actually no, because even registering a user is changing the state of the application, but you only do one successful registered user. So for example, I was fiddling around with waiting for the application to start up, and what does that mean exactly? When is it actually started? When are the services really running and available and talking to their databases? And I realized that the right solution was just keep retrying registering the user until it registered, and that means that the application then works. So that's there is that. It's sorry. Any questions?
Yeah.
Oh yeah, there is this that I use this await library to wait at most 1 minute until, and here I could pass in a runnable but I don't. I wrap the runnable in this wave method because to like catch exceptions and convert them into assertion errors, which is a bit weird, but it's needed by this availability library. If you throw an assertion error inside the until method, then it will be keep retrying. And actually, if you throw an exception, then it stops. If you throw an assertion error, then it retries. So I just throw assertion errors. I don't want to do that. Do the try catches over and over again. Yeah, and then you can, for example, abstract away this ugly stuff here. For example, actually the register user will return OK, return 200 even if he did not register the user, but will return an error inside the body of the response message. So yeah, stupid things like that you can hide in the tests. Of course, in certain tests you want to expose them, but maybe in these tests you don't care. All right. So there is that, and yeah. So we get to the container part. Why are containers so good for microservices? First of all, they are very easy to build. It's very easy to build Docker images. When I talk containers, these days it's Docker images. We'll see the future what that brings, but right now we are talking about Docker images. So as opposed to running Puppet and Chef and just installing stuff on a Ubuntu box that already has loads of things in it, and then you keep installing and whatever, anything can fail. Or of course you can snapshot VMs, but it's really hard to know what's actually inside there. They are big, so a small image footprint, so a container can be like 20 megabytes inside. Actually, for example, our front-end service is like 20 megabytes. It's tiny, tiny thing that has basically all the characteristics of a virtual machine that you actually need. So, because they're so small, you can actually fire up a local environment. I'll show that. That's very neat. And yeah, and then comes the dynamic orchestration. So so there are now the big race is with containers on the stage of container orchestrators. So because they are small and easy to start up and tear down and start up elsewhere or auto-scale or whatever the containers, then they can be much more dynamically managed than VMs. So of course you can also start up VMs and auto-scale them and down, but the container can start up in a few seconds just as long as your process starts to start. Takes to start, yes. So then you can do all kinds of fancy stuff with them. I will not go into the details of that, but yeah, that's a good thing. Remember that container orchestration. Yeah, and for testing, they give you the ability to just create ad hoc environments. We are right now doing that with a customer to just like you create a branch. It fires up an environment for it because why the hell not? Because it's just so easy. And you can have single-use environments. So during automated tests, you can just start up an environment, run tests on it, tear it down. That's it. You don't have to worry about. For example, with my register user test, it would fail if the user was already there. I solved it by completely destroying the whole application after the test is finished. Of course, you wouldn't want to do that. It's too slow for like doing it after every test, so you have to be a bit careful, a bit optimized there to. That's why then I did deleting the customer. But yeah, but for like a whole test suite, it's completely doable. Yes, and this is to remind myself that it's demo time. So yeah, so starting up the application. kubectl, first of all this. I'm using Minikube here, which is, so Kubernetes is a container orchestrator. It manages a set of virtual or not virtual machines and runs containers all over them, where it feels like it's the best to start up a particular container. It manages things like auto-scaling, so if a container has too much load on it, it can start up new ones, and it load balances between them. So it's a very advanced features that actually, with virtual machines to get them out of Amazon, you will have way more work to do than you do with containers on Kubernetes. It provides an internal network for the containers, and on that network it provides DNS, which means that you can just say that I'm going to be talking to the HTTP / order service port 80. And that's it. Order service, the DNS name will be managed by Kubernetes to map to your actual container or even multiple containers that have been auto-scaled up, for example, and your client doesn't have to know anything about it. So you no longer need all the fancy Netflix tools for client-side load balancing and service discovery, and all that is handled just by a virtual network under your application, which is pretty cool. And all that you can get on your machine. So you will use the exact same deployment descriptor on your machine than you will use in production. You don't have to make any changes. So yeah, I will can quickly show the deployment descriptor. So Kubernetes. You see it? Is it big enough? So this is how it looks, for example. Okay. Then I have to touch it. Don't break it. So yeah, so here you can see a deployment is saying that the order service container will be deployed. Right now in one replica set, actually the auto-scaling is missing from there. It's very easy to add in, but there were some bugs in the application that kind of was behaving weirdly when the container did get auto-scale, so for now it's not there, but it will be soon. And you define a service, so the service will be the thing that you call, so the orders, this one will become a domain name, and will be backed by any containers inside that orders deployment. It's a bit lengthy description of things, that's not that nice. I would prefer just to have a service and just tell it what the image is, and that's it. But it's still pretty good. And it maps very nicely with what you want from a microservice application. So Kubernetes actually has a very good understanding of your microservice application. Like when you launch VMs on Amazon, Amazon doesn't really know what's on it, just VMs for it. But Kubernetes understands that these are services, and actually there are already monitoring tools that can extract this information from Kubernetes and can immediately display you like these are your services. And you don't have to like somehow configure it to somehow configure it to say that this bunch of VMs is actually like one service or something. It knows that, so it's all that information is in there. I'll show you how that looks exactly. So we'll launch the application. kubectl apply complete demo YAML. No. So first I need to make a namespace for it.
When you mentioned Minikube, in what sense did you do it?
Oh yeah, so Minikube is a VM running on my machine right now, which hosts a Docker daemon and a bunch of containers inside that daemon which make up Kubernetes. And then my kubectl tool is talking to that Kubernetes as kubectl. You pick a Kubernetes cluster and you control it with kubectl. Yeah. So this kubectl now is talking to that VM on my laptop. Everything would look exactly the same if I was running a Kubernetes cluster on Google Container Engine or wherever, but this is now, trust me that this actually runs on my laptop. Yep, and there we go. So I have here, you can see we are watching the kubectl get pods. Yeah, so Kubernetes doesn't have containers, it has pods, but we don't. What's wrong with this thing? Yeah.
Maybe overheating.
Yeah, it looks like that. But why is it overheating? There is nothing. Then we're fucked. Yeah, temperature.
Maybe because of the boots.
Sorry?
Maybe there is no, there is like less space
Could
at the bottom of it. So the lamp, from the lamp,
Never happened before. Isn't there like a push? Ah, okay, so yes, it has a leg. Can be pulled out. Okay. Now we just wait a moment for it to cool down.
Put it outside. Let's open the window.
Yeah, sure, go ahead with some questions.
You mentioned about testing your microsystem, same application. Now you're looking at an example where there's a front end. How does this front end actually compare to your market using framework to actually to get rid of this pitfall you mentioned during the first part of the talk?
I didn't.
Actually, the system is built up out of, say, different microservices, and you said it's very, there's a danger that you actually test in different microsystems because you miss your entry point. And you said you actually need some framework just to have an entry point. Now in the socks application, there's a front end. Does it still apply, or does it?
Well, I think I could have hidden in the test the fact that it's calling the front end, but yeah, so maybe that particular detail shouldn't be also in the test, and we should just say registered user and not say front end dot registered user. Is that what you mean, that the front end appears in the test, so the test knows that it's talking to the
Yeah,
front end?
actually I can imagine that a lot of microservices applications built out of microservices do have sort of front end. So I think that would be a logical place to do end-to-end tests.
Yeah, of course. I mean, you will talk to the front end in the end. It's just a question whether you want that to be visible in the test or not. So, because like, of course, even what I showed that you shouldn't be talking to all kinds of backend services and stuff. That's like, I didn't mean it like you shouldn't talk to them. Your tests might very well, or your framework might very well talk to them, but the tests should not know about them. So how you, right, so that let's say that the test exposes register user, how that exactly happens should not be relevant for the test. So you're right that in a way that the fact that I have like front end in there, that's not nice. How we do that? Okay.
Also, like, because you said like the main advantage of using this testing framework is that you are abstracting away from like implementation details.
Yes.
But actually, in this test framework, there was also like part that is, yeah, indeed abstracted, like the spec is without details, but the implementation itself is also in the framework, right? Like the register method. So, for example, if something will change in a service that makes test failing, there will be failing also in this solution, right? Or not?
Yes. Keep saying yes, but you go and change your framework. It's in one place. So the pitfall I was talking about is when all those details are in every test repeated, because you're like making, for example, the REST code. So
okay.
And then you don't have that single place. You
okay.
will
So
go to each of your tests and need to change that.
Okay, so if some implementation detail changed, I can change it in the implementation part, but not in the definition of tests. That's the advantage.
Exactly.
Okay.
And you will have lots of tests,
Yeah.
but just one framework to manage.
Yeah.
All right. So we have, right, this looks weird. Yeah, so you did not see the glorious starting of the application, but you will see it again anyway. So, so yeah, so you can see these are the actual containers running, and these are the endpoints for each of the containers. So these are practically the services. So with a service now, unfortunately, I can't show you that I probably wouldn't have time to. Oh shit! Yeah. Okay, so I will start yeah, we have. I'm running out of time, so I'll just start the test and show you what happens then. Yeah, so that's what Kubernetes sees. It's a yeah, I can like go to this IP address now and open the socksshop, which I found Chrome. Oh yeah, that's this. And it's yeah, local IP address. Very, very nice socks. The holy socks, fit for Messiah. Oh, and this is, by the way, open source. So on one hand, you can use this socksshop to play around. It actually doesn't just have deployment descriptors for Kubernetes, but it also has for Mesos, has just a Docker Compose file. There is lots of good stuff in there. And you're welcome to contribute to it also. So like fix the auto-scaling and stuff like that. Write more tests. Okay, so so I'll just run the test now. Show you how that what happens then. I need to tear down the application. kubectl. Just delete the namespace in which the application was created, and it's all gone. It's gone. Containers will be gone soon. Yep. And we run the test. So where is IntelliJ? Oh yeah, this was the cucumber thing, but yeah, I'm basically doing this sometime. Right, I found it. Okay, so we will run this customer registration test. And I'll show you in the code what's going to happen. Yeah, so this, yeah, the test we have already seen, but the interesting part is the Spring configuration for the test. Here, you can see that it actually creates a Kubernetes client, so it will talk the same way to Kubernetes as the, yes, you can, if we go back here, now we can see already, you see the application is being started by the tests. Because Kubernetes also has a nice REST API, so whatever I did through kubectl, I can do through the test or through the Java client for Kubernetes. You can see here it was creating socks namespace, starting the application, waiting for it, and actually, yeah, it's waiting for a successful login right now. So here, this is the actual part. I parse in this complete demo YAML file, or not parse, I load it into memory, split it at the 3 dashes, because apparently the Java client doesn't understand YAML files where these things are split up like this. And then I just go and launch each of them with this client.load command. And when the test finishes, I go client namespaces, my socks namespace, delete, and it tears down the application. Yeah, user test customer logged in, and it probably will fail on something now because it's yeah, application is still okay. It's still not completely loaded. Yeah, this is graceful degradation, microservices, beautiful. You see, stuff not running in the background, but still you get something. It's like when Netflix still works even though you can't play videos. Amazing, it's so useful. It was a few Saturdays ago. Okay, so I think this is waiting 1 minute. We'll be over soon.
Have you heard about ChatMonkey?
Yes.
So how this relates to this concept?
Well, that somebody should implement one for Kubernetes, and then we would have one. I think there doesn't exist right now for you could use Chaos Monkey to tear down the actual nodes. Look at this, it failed because it couldn't get the customer for some reason, and it already destroyed the application. Gone. Yeah, so you can see that most of that time was actually waiting for just the actual services to start up, which is not even on the containers or anything, that's just like Java processes to start up. By the way, yeah, Java processes do take time to start up. Compared to Node, Go, I know about the .NET one, but lots of memory, slow startup, so I hope Java 9 does something about that, because then there are very good tools for making microservices in Java now, but they should also do something about memory footprint and yeah, startup time and stuff like that. Though actually startup time, that's Spring's job to do something about it, because otherwise it's not that bad. You can use these microservice frameworks that actually are much faster than Spring. But Spring provides lots of nice features, so it's balanced. So there was some question I think I didn't finish answering, or Chaos Monkey. Yeah, so you can you could run, let's say you run a Kubernetes cluster with 10 virtual machines that is managing the containers over those 10 virtual machines, and then you can have Chaos Monkey shoot down the virtual machines, and that will give Kubernetes a tough thing to do. So like if those machines die because they have a bunch of containers running on each machine, then Kubernetes needs to reschedule all of those over the remaining nodes. I'd like to see that. I haven't tried it yet, but yeah. Or make a Kubernetes Chaos Monkey that actually shoots down containers inside Kubernetes. That talks to the Kubernetes API.
When you do a container with Spring, how much memory do you reallocate to the container?
I think right now, yeah, all of it. So like there is no limits on the containers.
You don't say like a gig or half a gig?
No. I don't know how the Java process inside is configured, because also there you can set number limits, so there is 2 levels of it, which is now pretty useless with containers. Yeah, but these containers, so containers have the ability to just eat up everything in the host, which is fine in certain scenarios, of course. You don't run like completely different applications on your cluster, let's say you just run this socksshop, then maybe the best thing you can do is just let them have all the memory they can need.
Do you trust Java?
Sorry?
Do you trust Java?
Yeah, you could set. Yeah, you're right. That, but actually, yeah, my experience with Java is pretty good in these terms of like setting memory limits. But yeah, in Java you have to set something anyway. So yeah, it would make you safer to set something on the container. That's true for some ways. Let's say run a big process that.
Is there like some dashboard for fetching the results tests ready that I can use with Kubernetes?
No, the tests really don't have much to do with Kubernetes.
Okay.
So these are simple JUnit tests that you have seen. There is nothing. So it's really on the test running side of what dashboard do you get out of it. So Kubernetes doesn't help you with the testing.
So what I mean, so tests are not made in Kubernetes?
No.
Okay.
These were completely standard Java tests that, and they were run by Spring. So
Okay.
yeah, so this is what you see here. This is the Spring configuration,
Mm-hmm.
and the Spring configuration actually, when creating the socksshop bean, it goes and starts talking to Kubernetes.
So there are like unit tests, but there are end-to-end tests.
Yeah, like you can use, I mean,
Okay.
JUnit is a unit testing framework, but actually end-to-end test in that sense, what JUnit does doesn't differ at all between end-to-end tests and unit tests, because it's just run all the tests. That's what you need from a framework like this, and give me a report on what test failed and why. In that sense, there's no distinction between
But
end-to-end and
in
unit
Kubernetes,
tests.
you define end-to-end tests, right?
In Kubernetes, you don't define anything. In Kubernetes, you run your application.
Okay.
So how Kubernetes helps with this whole thing is that you can fire up the application when your tests begin.
Okay.
But that's just Kubernetes' normal function to run an application, plus it has an API, so your Java tests can actually just starting up and just tell Kubernetes to start on the application and talk to the application and shut it down. That's what. So Kubernetes isn't doing anything testing specific here.
Do you have any experience with fitness for testing REST APIs?
Sorry?
Do you have any experience with fitness for testing REST APIs?
No, you can tell me about it. Yep, so no more questions. Thank you.
Shall we take a minute break and then laptop, or you want shorter, bigger break? Yes. Yeah.
I think that exactly